Finding solutions by graphing. Solutions will be where the equation or the graph, the y value is equal to 0, or where the graph crosses the x-axis. There are three types of answers. Two solutions would have the graph cross the x-axis twice. One solution would have the graph cross the x-axis once, or the vertex is on the x-axis. And no solutions, the graph would not cross the x-axis at all. Title of the first section is Finding Solutions by Graphing. In this section, we'll graph quadratic equations and find the solutions by using the graph. First equation, x squared minus 6x equals 0. To solve this equation, we can change it into an equation we can graph. Since the equation is equal to 0, we can write the quadratic equation f of x equals, using the equation x squared minus 6x. Once we graph this equation, we can find out where this equation is equal to 0 or crosses the x-axis, and that will be the solutions to the original equation. Graphing this equation, we want to find the vertex. We can find the x value of the vertex. If you remember from previous sections, the x value of the vertex is negative b over 2a. So we'll have negative. B is the coefficient in front of x, which is a negative 6. So we'll have negative 6 divided by 2 times a. A is the coefficient in front of x squared, which is 1. Negative 6 would be positive 6 divided by 2, which would be 3. So the x value of the vertex is 3. To find the y value, we can take the x value and plug it into the equation to find the y value for the vertex. So we'll have 3 squared minus 6x, but instead of x, we can plug in a 3. Solving for y, 3 squared is 9. Negative 6 times 3 is negative 18. So our y value would be negative 9. Putting the x and y together, the vertex of this graph would be 3, negative 9. We can also find the y-intercept. The y-intercept, if you remember, is equal to the value of c. Value of c is the last number on the equation. If there is no number, the y value would be 0. Using the vertex and the y-intercept, we can graph. The vertex is at 3, negative 9. The y-intercept is at 0. And the direction this parabola opens up, since we had a positive x squared. So sketching the parabola, we can go through the y-intercept, through the vertex, and the graph will turn back around. We're not sure exactly where it crosses yet, so we'll stop the graph right there for right now. Keep in mind we're solving for when this equation is equal to 0 or when it crosses the x-axis. We have one answer already. Since the y-intercept is at 0, we know one answer would be x equals 0. To find the second answer, we can use the axis of symmetry, which again is the line down the middle of the graph that makes both sides symmetrical. Once we know one answer, this answer is 3 spots away from the axis of symmetry, which means the other 0 is also 3 spots away from the axis of symmetry. Both of these solutions will be exactly symmetrical on both sides. And if you want to, you can continue the graph. Counting the numbers over, this would be a value of 6. So our second solution for the equation would be x equals 6. So there's two solutions for this graph. The graph crosses the x-axis twice. First solution, x equals 0. Second solution, x equals 6. Second question we'll solve, and last question for the section. Equation is x squared plus 6x plus 5 equals 0. Again, if you want to, you can rewrite this as an equation to graph f of x equals. Since the equation is equal to 0, we'll just take the left-hand side. F of x equals x squared plus 6x plus 5. Graphing from here, we can first find the vertex, or the x value of the vertex. Negative b would be negative 6, divided by 2 times a, which would be 2 times 1. Negative 6 over 2 would have a x value of negative 3. Once we have x, then we can plug it back into the equation to solve for y. Y equals, plugging a negative 3 in, we'll have negative 3 squared plus 6 times negative 3 plus 5. Simplifying, y equals, negative 3 squared would be 9, 6 times the negative 3 is negative 18, plus 5. Simplifying further, we'll add and subtract from left to right. 9 minus 18 is negative 9, plus 5 would be negative 4. So our vertex, we have a x value of negative 3 and a y value of negative 4. We can also find the y-intercept. Y-intercept again is the value of c in the original equation. The value of c was 5, so the y-intercept, y equals 5. And last part, we can find the direction. Since we have a positive x squared, the direction for this parabola would open up. Using this information, we can graph the equation using the vertex, the y-intercept, and the direction. Drawing the vertex at negative 3, negative 4. We also have a y-intercept at positive 5. And we know the direction of the parabola would be up. These 2 points will be connected. It'll cross the x-axis somewhere in between 0 and 3, but without knowing exactly where it crosses, we can't draw the graph through there yet. To solve it, we can use a t-table. If you use a xy t-table, you can pick a number where you think it might cross at and see if the y value is equal to 0. For example, we can take the first number, negative 1, and we'll plug negative 1 into the original equation. If it's equal to 0, that means one solution would be at negative 1. If it's not 0, then we'll have to pick some other points to see which one's equal to 0. Plugging in negative 1 to the original equation, we'll have negative 1 squared plus 6 times negative 1 plus 5. Simplifying, negative 1 squared would be 1, 6 minus 1 would be negative 6, and plus 5. 1 minus 6 would be negative 5, plus 5 would be 0, so the y value when x is equal to negative 1, the y value would be 0. Graphing that point, that'll be our first solution. Again, these solutions where y is equal to 0 or the graph crosses the x-axis. If you want to, you can draw the parabola, the right side, going through our first solution. So our first answer, x equals -1. Keep in mind this parabola will turn back around and go up to the left. And again, we'll find some other number where it crosses that on the left-hand side. Once you know one answer, you can use the axis of symmetry to find the other answer. The first solution is 2 spots to the right, so our second solution will be 2 spots to the left. Counting over, this would be at -5, so our second answer would be x equals -5. So 2 solutions, or 2 answers to the original equation, x equals -1 and x equals -5. Title of the last section today is More Questions on Finding Solutions by Graphing. In this section, we'll continue to graph and find these solutions by graphing. First question, and only question for this section. X squared plus 4x minus 4 equals 0. Again, we can change this to an equation. F of x equals x squared plus 4x minus 4. If we find out where this equation equals 0, we'll have the answer to the original equation. Solving for the vertex, x equals -b, which would be -4, divided by 2 times a, or 2 times 1. We'll have -4 over 2, which will give us a x value of -2. Solving for y, we can plug a -2 into the equation. -2 squared plus 4 times -2 minus 4. Y equals -2 squared would be 4. 4 times a -2 would be -8 minus 4. Y equals 4 minus 8 is -4. Minus 4 will give us a y value of -8. So the vertex x is equal to -2 and y is equal to -8. The y-intercept we can also find is the c value in the equation we're graphing, the last number, which is -4. So the y-intercept is at -4. We can also find the direction. Looking back at the equation, we have a positive x squared, so a is greater than 0, so the direction would be up. From here, we can draw our graph. Vertex is at -2, -8. The y-intercept is at -4. And the direction goes up, so we can start at the vertex, go through the y-intercept, and again this graph will cross somewhere at a positive value and also at a negative value. To find those values, we can use a t-table. By guessing points where we think it may cross, we can see if the y value is equal to 0. If we take the first point, +1, we can plug a 1 in to the original equation, which would be 1 squared plus 4 times 1 minus 4. 1 squared would be 1 plus 4 minus 4. 1 plus 4 would be 5, and 5 minus 4 would be 1. So if x is 1, y is 1. Drawing that point on there, the 0 will actually cross before we get to positive 1, but it crosses after 0, since 0 has a y value of negative 4. Since it crosses in between 0 and 1, our answer for this question, x equals, it'll be a number between 0 and 1. It'll be some decimal, some fraction between 0 and 1 that we cannot solve for by using graphing. Keep in mind though, we'll have a second answer. This graph will also cross on the left-hand side. To find that, we could use a t-table, or we could also use the axis of symmetry. The first 0 was in between 2 spots and 3 spots to the right. So it's past the second spot, but before the third spot. Same thing with the axis of symmetry. If we draw 2 more lines, the graph will cross after that second line, but before the third line. And counting the numbers up, this will be 1, 2, 3, 4, negative 4, and negative 5. So our second answer would be between negative 4 and negative 5. Again, it'll be some decimal, some fraction between negative 4 and negative 5, but we cannot find the exact answer by using graphing.